Hi. In the last video, we discussed about, we introduced the idea of velocity and displacement in addition to speed and distance, right? And we also captured, why velocity was relevant, and it helped us capture something which speed and distance were not able to capture, right? And we also calculated the velocity of two objects A and B. A was moving, both were moving at the same speed, but the position of A was changing faster when compared to B, right? And we calculated this. There is one other aspect with respect to velocity and displacement which we didn't touch upon, and that will be our primary focus in this call or in this video. And in other words, the depiction of saying that is, velocity of an object is 1 meter per second, velocity of A is 1 meter per second, and calling velocity of B as 0.33 meters per second is not an accurate way. And we'll understand why it is not accurate to call it this way, to state it this way, right? And just to summarize, let's take the example. So let's say that, we're saying that, speed is equal to distance over time, and velocity is equal to displacement over time, right? So speed means it is, rate of the rate of motion, right? Rate of motion. The rate at which the object, the distance covered, right? The distance covered along its path over time, right? That speed. Velocity is the rate of change, the rate of change in position. The rate at which the position of the object changes. And the change in position is nothing but your displacement. Sorry. So your displacement is actually your change in position. Right. So I think there's a bit of lag here. Yeah. So your displacement is your change in position. And if you really observe, your displacement is always the, in most cases, in all cases, your displacement will always be less or equal to the distance, right? When will it be equal to the distance? When person B also starts walking the same way. Right, when person B also starts walking the same way as A, which means that, in this scenario, your displacement will be the same as distance, right? The distance covered will also be 100 meters and the displacement will also be 100 meters. But in this case, because the person B has this behavior, the displacement is 100 meters, but the distance is far longer because the path goes zigzag, right? And the path, the actual distance covered by B is longer, right? So that's the idea. Now, what is that aspect that we missed with the velocity? Now, to understand that, let's take let's consider this example. Let's consider the third person, right? Let's consider three people walking now. So we have this person A who's walking and from the origin and takes the same step, right? And it keeps moving, and the speed is 1 meter per second. Now we have the second person whom we saw, right, from the origin, and this person takes for every second step, she goes back one step and then moves forward, right? So this is how this person moves. So the speed is again 1 meter per second. Now let's consider the third person. This needs a different color here. The third person has an even more different behavior. So let's say the third person has a tendency, for every second step, the third person goes back not just one step, but 3 steps. Which means, after taking the second step, this person moves back 3 steps. Right? So, this is how this is. And it goes like this. Right? Now, in this scenario, and the speed of this person is also 1 meter per second, right? Just to recap again, the distance covered is going to be different for all of them, right? And speed primarily takes care of distance, right? So that's why the speed is the same. Everybody takes 1 meter cover. They cover 1 meter every second, right? Now, given this example, let's calculate their velocities, right? Let's calculate the velocities after, say, the fifth second. Yeah, that'd be a good example. After 5 steps, right? Let's try to calculate their velocity. Let me use a different color. Okay, after 5 steps, what is their velocity? Now let's call these people, the 3 people, as A, B, and C, right? Now velocity of A is equal to the displacement by time, which is after 5 steps, the displacement would be, he would have moved 5 steps, right? 5 meters away, and which means that it will be 5 over 5, which is equal to 1 meter per second. Right? The displacement will be 5. Now, what about for the second person? Velocity of B. After 5 seconds, if you recall, after taking 5 steps, where will B's position be? This is after the first second. After the first. This is after the second. This is after third. This is after 4, and this is after 5. Right. So after the fifth, after taking the fifth step, the position, right, the change in position is going to be 3. So which means velocity of B is equal to 3 over 5, which is equal to 3 over 5, which is equal to 0.6 meters per second. Right. Now comes the interesting part. What would be the velocity of C? Now after taking 5 steps, where will C be? So here, this is after taking the first step. This is after taking the second step. This is after taking the third step. This is after taking the fourth step, and this is after taking the fifth step. So if you see, person C has actually gone 1 step behind. The origin is even. So which means that your velocity of C is equal to minus 1 by 5, which is equal to minus 0.2 meters per second. And that's the difference that we are talking about. If you see here, the displacement can actually be negative for some for the way some objects move, right? And what does this negativity mean? The negativity means that the object is not moving. The object is moving away from your target, right? So in this case, if you consider your target to be here, right? If you consider your end state to be this point, the fact that your objects, all the 3 objects are moving, but of the 3 objects, it's only the third object that is actually moving away from the target. It is not just moving slowly. At least object B is moving towards the target, but it's moving slower than A. But object C is not just moving slower, but it is actually moving away from the target, and that is the aspect that we didn't explicitly call out, and that is that's the other aspect of velocity, which means that your velocity has two parts. Your velocity has both a direction aspect and there is a numeric aspect. And the direction is shown by the sign, right? So all the other measures, the physical quantities that we spoke about, be it your distance, speed, distance and speed, all of them had only the numeric aspect, right? They did not have a direction, right? The value of the distance covered will always be positive because it is the length of the path that that particular object takes. So it will always have a positive value, right? Because speed is defined as distance over time, speed will also be positive. But whereas velocity, it always takes into consideration the actual change in position, and that change in position can be towards the direction of your target, or it can be away from the direction of the target. So that is where velocity and displacement, both of them, have both the aspects, which is your direction as well as your numeric aspect. Now, given this, how should we actually state is that the velocity? We should not say that the velocity of C is 1 by 5. We should rather say that the magnitude of the velocity of C is 0.2 meters per second. So this part is very important. When you're only focusing on the numeric aspect of velocity, the right way to say that would be the magnitude of velocity of C is 0.2 meters per second. So that is where when we said the velocity of V is 1 by 3. So this is incomplete. The right way to say this is the magnitude of velocity is 0.33 meters per second.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share and subscribe this with your friends. Thank you.